Hello dear viewers, welcome to TV Math Hub. In our today's session, I will be taking you through Jinja Joint Pure Mathematics. So in this video, we shall be looking at question number 6. We have so far looked at the solutions to questions 1, 2, 3, 4, and 5. And in case you haven't watched our previous videos on these solutions here, please check in this playlist. You'll be able to obtain the videos to these questions, that is 1 up to 5. So today we want to look at question number 6, which says, given that A is 215, B is 3, -17, are points on a straight line which meets this plane at a point T. Then we need to find the coordinates of T. So coordinates of T, T is a point of intersection between the line which is passing through A and B, and which is meeting this what? This plane, which means that to get the point of intersection, we must be in position to get the equation of the line first. Then we use the equation of the line and the equation of the plane to get the point of intersection. So to look at that, let us look at the solution. As we have said, we shall first of all get the line which is passing through AB. So we know from the general expression or from the general equation of the line, which says that R is equal to A, then plus lambda AB. This is the general equation of the line. So R is the general point on the line, A is this point here, then AB is a point which you can easily obtain using A and B. So let us first of all look at AB. So we need to obtain vector AB. Vector AB is same as getting B, which is 3, -1, 7. Then you subtract it from A, which is 2, 1, 5. Because we understand AB is same as OB minus OA. And this will be able to give us 3 minus 2 is 1. This will be -2, and this will be +2. So this will be A, B. And from there, it implies that our R will be same as A. What is A is 2, 1, 5. And what is B? AB. So AB is 1, -2, and 2. So R is a general point on the line, which is X, Y, and Z. And this one here will imply that this is equal to 2, 1, 5, then plus lambda 1, -2, and 2. So that is basically what we are having. From here, we can as well manipulate this further to have this as X, Y, and Z, which is equal to 2 plus lambda, 1 minus 2 lambda, and then 5 plus 2 lambda. So that is basically what we shall have. So from here, we can go further and say that for this matrix to be equal to this, it means these components must also be equal. And for that case, we can have X as 2 plus lambda. We can have our Y as 1 minus 2 lambda. We can have our Z as 5 plus 2 lambda. So for that case, we shall say that these components X, Y, and Z must be satisfying this equation of the plane since they are intersecting at the same point. So at the point of intersection, we shall have these components satisfying the X, Y, and Z components in the plane. And for that case, we shall have 4 into 2 plus lambda. Then we shall have 3 into 1 minus 2 lambda. We shall have -2 into 5 plus 2 lambda and plus 17, which is equal to 0. So this will give us 8, then plus 4 lambda. This is 8 plus 4 lambda, then plus 3 minus 6 lambda, then minus 10 minus 4 lambda, then plus 17, which is equal to 0. We can try to simplify this. 4 lambda will go away. We remain with -6 lambda. Then this is 8. This is 8 plus 3, that is 11, minus 10, that is 1, then plus 17, that is 18. So we shall have plus 18, which is equal to 0. So minus 6 lambda is equal to negative 18, giving us lambda as positive 3. So we have got the value of lambda. Remember, we need the point of intersection, and that point of intersection will be the point which is satisfying these components here, that is x, y, and z, when we substitute for lambda equal 3. So when we substitute for lambda equaling to 3, we can now have these components, x, y, and z. So we shall have x, y, and z will be equal to, so let us have this as 2 plus lambda, that is 2 plus 3, then 1 minus 2 times 3, then 5 plus 2 times 3. We are substituting for lambda in these components, and this will be giving us 5. 1 minus 6 will give us negative 5, and 5 plus 6 will give us 11. So this will be the point of intersection. But we need the coordinates, so don't forget to have your coordinates in form of the x, y, and z, and this will imply that your t will be 5, negative 5, then 11. And this will be your solution. So what we required was to get the coordinates for t. So don't leave your answer in the column of form, in this form here. So you have to conclude your answer in this form. So this will be the solution for question number 6. Please don't forget to subscribe to this channel and share, like, and comment to this video.
Yeah.